Welcome back to the Hyperbolic Coding Chamber. We are back once again. The confines of time have conspired against us to create not only one, but 2 days where it is possible that we might freak it. So, yesterday we thought we might. Today we actually probably will. Fortunately, before we start the session, we have tons of comments to go through to help stall. And I try not to pre-read too much, just so I can read it. But also, I get distracted a lot, so I try not to get too sucked in and not respond right there. But we have some comments today. Actually, a lot of comments, actually. We have a comment from Khan. Oh, wait, actually, I forgot to say. Today, we are back on the creatinine. Okay, so if you're not, it's not creatinine, it's creatine. We're trying to get swole again. And I mean, this is a must-have. So I was talking with I was in a VC with the CEO of LeetCode. We were talking about creatine, directed acyclic graphs, things of that nature. And somehow we got onto the subject of getting swole. So that's kind of where we're at. So we have a comment from Can Kunawat, which is a pretty cool name, but an even cooler profile picture. How long do you plan to continue this challenge? Continue this challenging. How long? I mean, I actually don't know. I think at this point we're just doing it. Probably for the rest of our, probably for till the end of time. Maybe, not sure. Current goal is to focus on 1 day at a time. I think the goal, I don't really know. I think I just try to focus on 1 day at a time. And this might be a necessary evil. Just as I read more, it seems to be like a recurring theme that if you focus too much on how long you have to go, it kind of just makes me want to stop. So I try not to focus on how long I plan on doing it, and just try to focus on. I try really hard to just focus on today. There's definitely something I remember reading about this. Oh yeah, I think it was something about Hell Week, and when they were training SEALs, and pretty much Hell Week is a week where they pretty much do in just absolutely insanity in terms of physical exertion. But I think what the person was saying in the book, I don't know if it was Neil something, it was something about Soul Survivor. I don't remember, but basically, apparently he was saying that everyone thinks it's a physical exercise, but it's really a mental test to see who keeps going when they're down and out. And I remember the author writing that he was surprised that so many people were quitting so soon, because what he was saying is all we had to do was focus on the current challenge. But I think he was saying a lot of people who were quitting would focus on how long they had to go, or how there was still 4 more days left and stuff like that. And I fall into that trap all the time. So I actually don't know how long I plan to continue. I'd like to just finish all the LeetCode problems, and then maybe we'll move on to Euler project, or maybe we'll move on to something else completely. I have no idea. I'm not actually certain. But finishing all the LeetCode problems would be pretty cool. Then we could lay this to bed, and that would be pretty epic. But yeah, I'm definitely comparing LeetCode to SEAL training, and LeetCode training is actually harder. So after we finish all the problems, we might just have to go through Hell Week. So everyone in the HCC is invited, and we're gonna stage our kind of own version. But those guys are nuts, so props to them. But yeah, I think we'll probably try to finish all the problems. Maybe we'll do Euler project next. After I surmise we'll finish the problems, I surmise we'll finish all the LC problems at day 500. It's day 200. Or day 600, I think, is when we'll finish all the problems. So it's about 400 days from now. And when I think about that, I actually don't feel too bad about that, because I think we're at the point where it's difficult some days, but now I know it's okay to run. It's okay to walk some days. So it hasn't been that bad. But getting to 600 doesn't make me think it's going to be too bad. But I think we're kind of blowing through the easies. So we should do, I think we should finish all the easies in probably 100 days. Or I was thinking 2 months, so that would be 60 days. Oh no, it'd probably be 100 days. Then we have 1,000 mediums or 1,300 mediums. I feel like after 400 mediums, it should probably become as fast as the easies. So now it'll take another 200 days. And then there's like not as many hards. So I think around day 700 we'll have done all the problems. That would be pretty cool. And if I'm not alive, someone will nominate the next person to HCC that will continue the journey. If I die, you will continue the channel for me. So Can will continue if in case we perish. We have Aran Haikaya. Nice work, man. I'm just starting LeetCode. A feels strong, Dan. Stay strong, brother. The beginning. The LC begins. That's pretty cool. That is pretty cool. I feel like we're just starting too, so we're all just getting started in the end. And then we have a comment from Ishan Jagani. Enjoyed watching the very first video. I'm also, so I got some questions to do, man. Hey, feels strong. Welcome to the hyperbolic brainwashing chamber. Dang, I honestly feel like some people are gonna start flying past me. So this is pretty hype. So that's always pretty dope to see. LC, a necessary evil. LC may be a necessary evil. We trade time and hopefully we get something more back. And then we have Neil. Oh wait, it's Niall. Do Atomic Habits really work? Since you have all this community and habit of uploading daily, have you found it way easier now than in the beginning grinding LeetCode? Found it way easier than now in the beginning. I definitely think it's easier now. Yeah, I think I had a breakthrough recently about the Atomic Habits thing. I think this is my mad scientist theory. I think it's like a two-pronged thing. Because I tried Atomic Habits for some things. I don't even know if it's Atomic Habits. I didn't really try anything in the book. All I got from the book TLDR is that if you stick at something, you'll get something back. There's also, I think there were some really good points about making it smaller, but I think that's the cheat code. So yeah, maybe that is why. But I tried the Atomic Habits thing, and for some things, if I'm trying it correctly, but I don't really know, I was just trying some random stuff. It's possible that it's exactly what I was doing. Oftentimes I'll read the book and then just implement what I was trying to figure out from the book, and then I'll just toss the contents of the book away. So I can't tell if the current process, is probably a result of reading a book similar to Atomic Habits, but I don't know for sure. I forgot where I was going. I guess what I'm trying to say is I think it's a two-pronged. This is my mad scientist theory about this. I think the Atomic Habits, or the habitual tolerance, you show up, you pretty much do it every day, but you're really practicing showing up. I think it's complicated. We would need a drawing surface, but it works and it doesn't work. And I think the key is two phases. I think you have to do something. It's so complicated. Basically, this is what I think. I feel like there's some things that showing up every day, you have to get over it, a balls plateau. The beginning of something just sucks. And then showing up every day helps you get over that until it gets you to the point where you can get over showing up and you have enough competency to enjoy doing the thing. And then from there, you get access to a small stream of rewards that can encourage hyperfocus. And with the hyperfocus plus the daily returning, I think it ends up being a nice cycle that returns. The issue, I guess the two-prong being the thing that you're doing eventually has to have some sort of small stream of rewards, right? Or otherwise it feels kind of hard. And LeetCode is kind of like that. The first 100 days is very difficult. then we gained like I wouldn't even say we're competent because all we can do are easies, but I kind of get it a little bit. And then after that first 100 days, kind of just became fun. And so now when I'm sitting there focusing on the problem, there's a small stream of rewards that kind of feels like scrolling. Well, it doesn't feel like scrolling, but there's a small stream of rewards that is feeding something. And that small stream of rewards encourages me to go longer. So sometimes I'll do it for 30. I'll say I'm only going to do 30 minutes, and I'll still do an hour and a half. Because there's like a small reward system there. It's not like I'm forcing myself. It's kind of like, it's kind of fun now. But this is just ideas. A two-prong thing I was thinking is that the everyday thing helps you get over the helps you get over the okay plateau, or the part where you have to build competency to enjoy something. Or it also helps with showing up, because showing up is the hardest part. And then hopefully the second phase, or the second prong, is that hopefully you get to the portion. Well, this is the second part. That's kind of a question mark. Hopefully you get a small stream of rewards from doing the thing, or maybe you're not over the hump yet, and that's where it's hard to know. I feel like programming is like that. So I think I spent a long time learning how to program in school, but I was already doing stuff outside of school for it. But there's like a professional programming that's kind of fun, but it took a while to get here. Now I kind of see why people are interested in new libraries that come out, new frameworks, but it kind of took a long time to get here. And school kind of let me get there because I just kind of stuck with it until eventually you get enough of it and you're like, okay, I kind of get it. But I try to do the everyday thing with other things, for example, game dev, and it didn't quite go as well. And it was kind of hard to realize, but I didn't really feel like there was a small stream of rewards in game dev. Now, is that a function of me not doing it long enough to get over the competency hump? Hard to know. That probably is why. But at the same time, there are other so that's kind of what it's not super set in stone or anything. It's just kind of things I think about. Everything's pretty muddled, to be honest. But TLDR, I don't know what I was talking about, but I definitely find it way easier now than in the beginning. It doesn't feel hard to show up to do the problems, and sometimes I promise I only do 25 minutes of 30, and we still end up doing an hour or an hour and a half. Some days we just do 25 minutes of 30 minutes, so we don't burn out. But it's definitely much easier now. I would say after day 100, it just became fun. I don't know how to explain it, but it definitely became much easier. And maybe that's where we need to get with game dev, but it's hard to know. So I'm also doing a whole bunch of other tests with these things in the background, so I don't talk about them too much, because I don't want to change my ideas too much, or change what I'm saying too much, because I'm just in the video starts, I'm just talking. But in the background, I try to keep a Notion journal of what's working and what isn't working and stuff like that, and things next to try. So I'm always trying different stuff, and the newest change is to try. I've been trying the everyday thing with things I already get a small stream of rewards from, and it's already kind of working. So that is pretty cool. But it's always tough to get over that competency hump. So that's a whole other thing to solve. Maybe that's what James Clear is getting at. All this to say, Atomic Habits, I think Atomic Habits, or there's another book called Mini Habits, I think it's flames. It may be the cure-all we've all been looking for, but I do not know. When we solved all the LeetCode problems, then we'll be able to say that it works, hopefully. Or maybe we've already gotten enough out of it. I don't know. Also, since I remember you said you have your master's, this bachelor is supposed to be this easy. I started school a week ago, and the courses are almost ridiculously easy. Hey, maybe that means, okay, must Nile be stopped? Maybe that means you're already beasting. For coding, we have C#, 6 projects. That's the whole course. Math, we have 40 small assignments, 2 tests, and that's it. Granted, those are all introductory class, but still, really hoping the difficulty ramps up. It's just embarrassing. Hey, I mean, it might be that you're already killing it. If that's the case, that's kind of flames. And if you have the extra time, maybe this is a blessing in disguise. Because since the coursework is easier, now you can supplement or have free time to pursue your other interests, or maybe build your own things. or you can learn even more. So it's this is kind of the ideal structure, actually. Maybe this might be the ideal structure. The beauty here is that the I guess it depends, on the school, but if they're setting the floor instead of the ceiling, that's kind of dope. Because if they set the floor, it means you're always succeeding, and then based on your own interest and your own, how you're feeling, you could make projects on the side. You could learn more. You could practice LeetCode. You could draw, run, dance. You could do anything. So that might be actually kind of flames. This might actually be flames. Because I remember some classes I had a lot of free time. I would be working on a game or something like that. Or I used to make mobile games. So that's what I was doing in my free time. Now I wish I did something else with it, but that actually might be flames. That actually might be flames. As I know, yeah, I think it might be pretty cool if they set the floor. So it seems like their destiny is truly in your hands, which could be pretty cool. That doesn't feel strong, man. But yeah, I would say also asterisk. There's a great video by Jack Conte called I think it's called All Advice Sucks or something like that, and I would definitely attach that to this video. I wouldn't take anything I'd say too seriously, because I'm just trying to find a system that works. So, but I was also, maybe I can link that video because it's a pretty good video. But that being said, we have stalled long enough. Thank you for the comments. If this is something you're interested in, you should definitely join the Hyperbolic Coding Chamber Discord, or the Hyperbolic Storage Chamber. As you can see, the storage is growing. We also plan to throw a party in this room once we hit day 500. We're all gonna get sturdy. So if you're interested in that, you should definitely join the Discord. So that is currently where we're at. And yeah, I wish I had more concrete. I wish I would have had more concrete things to say, but it's all a process. Maybe we should use Zettelkasten, courtesy of the Copy Ninja. But yeah, I'm just trying to figure out a system that works. But I definitely think, I gotta be honest, I definitely think there is something to doing something every day. I'm not exactly certain what it is, but I don't think it's something I'll ever stop doing. Maybe we might stop LeetCode, but the system of doing something every day is. I think the only videos up on this channel are the LeetCode videos. But I tried this with a bunch of other stuff and it really changed things. So some of those videos are hidden, but it's been pretty dope. So yeah, if there's anything, I would say the everyday thing is it, and it's definitely easier to start. What worked for me was just keeping it really, really, really low effort. I think we started with 10 minutes in the beginning, but that being the case, we can't stall any longer. We have to jump into it. Thank you for the comments, gang. And we need to also, I don't know if this is illegal, but we need to make a group, a Discord LC account so people can use premium, because LeetCode is stopping the people from getting the information they need. So I don't know if we'll make one. We might get banned, so it might be illegal. So I'm gonna check their terms and policies, see if they actually have something on sharing sessions. But let's just say an anonymous username and password will be available, maybe as part of the channel names that just might happen to help you log into LeetCode, and it just happens to you that 200 people might be using it. It might just be kind of crazy. But I'm going to talk with the LeetCode. Me and the LeetCode CEO are going to hop into VC later and figure that out. So that being the case, we have more problems to churn through. This was the 3D based problem that, I'm going to be honest, seems relatively impossible. So we're going to sidestep that for today. And I think we're at the point where a lot of the problems don't have too much frequency. So average salary, number of recent calls, crawler log folder, Yeah, I can't wait till we get to the mediums. But this is important too. So we're gonna do a classic hour session, and then yeah, we'll just see how far we get. So we're given an array of unique integers, salary, where salary sub I is the salary of the ith person, which means we have I plus 1 people. Oh no, we have I guess we have n people. Return the average salary of employees, excluding the minimum and maximum salary. I think we could sort this, but it would actually just be faster to do this in linear time. So we need 3 variables: sum, min salary, which would be equal to infinity. Actually, we can just set it equal to salary sub 0. I have a max salary, which is equal to salary sub 0. And then I'm thinking we're going to need... Actually, no. And then we should just be able to return sum divided by salary.length minus 2. I think. So let's see if this makes any sense at all, if we're just talking nonsense. But I think we should be able to say min salary is equal to math.min of min salary or salary, and then max salary is going to be equal to the same thing. Oh, salary is the array. So we'll just call this S. And then we'll say sum plus equal salary. Sum plus equal S. Then from here we can say sum minus equal min salary. And I think this should work. Oops, I gotta change this to max. Nice. Then we have number of recent calls. This has a lot of dislikes, so maybe this is harder than easy. So you have a recent counter class which counts the number of recent requests within a certain time frame. Implement the recent counter class. Initialize the counter with 0 recent requests. Int ping t adds a new request at time t, or t represents some time in milliseconds, and returns a number of requests that has happened in the past 3,000 milliseconds. Returns a number of requests that has happened in the past 3,000 milliseconds, including the new requests. Specifically, return the number of requests that have happened in the inclusive range t minus 3,000. Oh, t minus 3,000 to t. So if we get a request at t equals 3,500, they want the requests from 500 to 3,500. Can we guarantee that every ping is going to be strictly non-decreasing? Oh, it does say strictly increasing values of t. If that's the case, then it's already sorted. This is an interesting problem. So given a value, so for example, if we get the value 1, we want the values that exist between negative $2.99 to 1. Inclusive of 1. That would be one value. Could we 2-pointer this? Seems possible. They only give us one example, which means we might get got. If we 2-pointered this, we'd have a pointer, right? If we do a ping for a 100, right? We'd have a pointer which starts at 0. We would check. We would check that 100 is less than 3,000. 100 minus 3,000 would give you negative 2,900. We'd only move it up if t minus 3,000 is greater than the time that we're currently at. In the case where the first pointer, there's only going to be one pointer now that I'm realizing. The case where the pointer is only 0, if we do 3,000, we do 3,000 minus 1. 3,001 minus 3,000, you'd get 1. Which means that 1 is greater than or equal to 1, which means we would just return the current index, which would be index 3 minus index 0, which would give you 3. Then we do 3,002, and then we'd say 3,002 minus 3,000 would give you 2, and 2 is, we want to say less than or equal. No, 2 is greater than. Right, if the pointer value is less than the subtracted value, 3,002 minus 2,000, 1 is less than 2, which means we'd want to increment until our value is greater than 2. That would give us index 1, then we could do index 1, which would, we do index 4, which is the last index just added. Index just added. That would be 2. 1 is less than 2, so we pretty much add 1 to the index until our value is greater than the beginning of the interval. Is there a case where that doesn't work? We don't actually. Good thing we don't have to return the time elapsed, and we just have to return the number of values that remain. Because if we had to return the time elapsed, this would be awful. What if we add just another test case? Alright, I think this would work, but I can't figure out why this has so many dislikes. Makes me feel like I'm missing something. I can't think of a case where this wouldn't work. Let me think a little bit longer. strictly increase. I think we should be fine. So I have request, which is going to be an array of numbers. All right, we don't really need the constructor. We're going to say ping, right? To do ping, we're going to say this dot request dot push t, and then we're going to need to 0 to start, and then we know. I have to use the bathroom so bad. We'll know. Oh, we'll know given a boundary index. Given a boundary index. Oh, my insides are a swamp right now. Boundary index is going to start at index 0. We'll take the time that they just gave us. We'll do t minus 3000, and then we'll check boundary index. If this that requests a boundary index is less than the subtracted time, then we want to increment. So we'll say while requests of this dot boundary index is less than this dot request of this. Actually, it's just going to be t. I can't even think. And then I think we can just return. I think the abdominal spasms have ended. Then we can return this dot requests dot length minus this dot boundary index. Nice. Yeah, that one, my stomach started going crazy. The LeetCode file system keeps a log each time some user performs. The LeetCode file system keeps a log each time some user performs a change folder operation. The operations are described as follows. Operations are described below. // move to a parent folder of the current folder. If you're already in the main folder, remain in the main folder. If you're already in the main folder, remain in the same folder. // remain in the same folder. // move to the child folder named X. Always guaranteed to exist. You are given a string. You're given a list of strings logs, where log supplies the operation performed by the user at the ith step. The file system starts in the main folder when the operations in logs are performed. The file system starts in the main folder. File system starts in the main folder. Then the operations in logs are performed. Return the minimum number of operations needed to go back to the main folder after the change folder operations. I think you could do this with a stack, but now I'm thinking you can just do it with a variable. This would be 1, 0, 1, 2, 2, 3, 2, 3. So it looks like we will add if it's some kind of string, if it's changing to a child folder, we'll add 1. If it's // we'll ignore it. And if it's a // we'll subtract 1 only if the value isn't already 1. I wonder if the tag for this problem is simulation or stack. I don't know if this will work, but let's try it. Let's try just using a variable instead. We'll call ops equals 0 for let const op of logs. If op, there's no contains function. I think there's includes. If it includes a D, we'll just say it's a directory change. We could also use regex. If it includes a D, then we're just going to say op plus equal 1. Else if op equals .. we'll say op is equal to, if op equals 0, 0, otherwise op minus 1. What's the problem with this? Oh, it should be ops. So in this case, we do 1, 2, 1, 2, and we should return 2. Oh, the directories can be named anything. Okay. I see. So then we'll just try. Well, what style the directory's in? There's only 3 operations. How about we just say if it doesn't include a dot, then it must be a directory change. Nice. Minimum number of moves to seat everyone. There are n seats and n students in a room. There are n seats and n students in a room. You are given an array seats of length n. There are n seats and n students in a room. There are n seats and n students. You're given an array seats of length n, where seat is the position of the ith seat. You're also given the array students of length n, so we have an array seats and students, both are length n, where student sub j is the position of the jth student. You may perform the following move any number of times. Oh, I forgot to check if the last one was simulation. Oh. You may perform the following move any number of times. Increase or decrease the position of the ith student. Is the position of the jth student. You can increase or decrease the position of the ith student by 1. We have seats 315 and students 274. I see. This is an interesting problem. I think it's giving us a story, but what it's really asking for us is the distance, the smallest distance that all these numbers, the smallest number that all these numbers can be subtracted by, the smallest number that can be added to all of these numbers to make them equal to this number. So if we had 4 plus 1, we get 5 plus 5 would give us 10, plus 9 would give us 19, then we'd have 19, right? And then we'd have 5 plus 1, which would give us 6. 6 plus 6 gives us 12. If we do 19 minus 12, we get 7. And if we do 5 plus 3, we get 8. Plus 1 is 9. And then if we do 7 plus 4 is 11. Plus 2 is 13. 13 minus 9 gives us 4. Feels like we could just do seats dot reduce a plus b, and then we'll wrap the whole thing in a math.absolute value. So we'll do students dot reduce a plus b. Oh, I really thought we had it there. Okay, this was my Hail Mary. It feels like there's something there that we're missing that we could do the addition based thing on. 16. The second best option might just be to match every student to a seat, but its closest seat, which would be closest to its current position. To do that, we'd probably want to sort the seats first. Should be n log n time. And then from here, maybe what we'd want to do is we could do a binary search to find the next available seat. That would give us the moves. So we'd have let moves equals 0. And then we can write a binary search which is going to take an array of numbers, as well as the target, which is going to be a number, and it's actually going to return a tuple of numbers. And the tuple of numbers is going to be the potential actually no, just return one number and we'll take that logic out, which should get us closest to the value that we're looking for. So let left equal 0 and let right equal r.length minus 1. So while left is less than right, we're going to want to calculate our pivot, which is going to be the math dot floor of, and I forgot how it works. I'm pretty sure it's left plus left minus right over 2. So if we had something like 2 and 5, we would do 5 right minus 5 minus 2 would give us 3. Half would be 1.5, floor would be 1, plus 2, which is left, would give us 3. See, if r sub pivot equals target, I'll return target. R sub pivot is, if it's less than target, right, the array's already sorted, then we know that everything before this is also too small as well. So we can say left is going to be equal to pivot plus 1. And then we can just say else, or we'll just duplicate it anyway. Right is equal to pivot minus 1. If we don't find the number, then this gets to the question of what we should actually return. We have 1, 5, and 8. Let's just say we're searching for 4. Right, our left is going to be 0, our right is going to be 3. Right, we did 3 minus 0 give us 3 over 2 would be 1.5, floor would be 1. So you get 5. 5 does not equal 4, and 5 is greater than 4. So right is going to be equal to pivot minus 1, which is index 0. So we should return left then. But I think we can make it less than or equal. So here we're given an index, right? And it's pretty much going to be the closest index to the number. Right, and just to make sure that this works, to start, we can just print out console.log student sub seats sub index, and it should give us the closest seat to 19, which should be 19. A different case, but the first student is index 2 and the closest one to it is either 3 or 1, and we get 3. I think our index, I think our thing is broken. We're getting 4. We should be getting... Wait, we should be getting 1. Why are we getting 4? Oh my god, I'm returning target. Should be returning pivot. Right, now we get 3. We get 1. I get 2, and the closest value is 2. Now, it might be that we have to sort students as well, but I kind of want to see, how can we know without... Either it found it, I always want to take the smallest one. And then we want to remove seats as well, so we can say seats dot So if we have something like 2, we start with 4. We you'd find 5. Then we'd say student, which is 5, or student position, which is 5 minus seat sub idx, which would, well, student's position would be 4 minus seat sub idx, which would be 5. And we should get 1. Loose plus equal 1. Then we'd splice where we're at the seat index and delete 1 item. I'm not exactly certain what the problem is. I think this should fix it. Maybe not. I wonder why we're I guess taking us out of bounds. And we only wanted to return a value within the bounds. So say if it equals our length, return left minus 1. Otherwise return left. And if it gets stuck again, then we probably need to have handle both. Seat sub IDX Yeah, I think we need to do both. So we'll just do it like this. Undefined. So it matches 5 and 4. Matches 5 and 4 when it should match 5 and 7. Yeah, I thought we might have to do this, but I think it does seem like we have to sort students. I see. I think if we remove all the console logs, this is better. I wonder if we even needed all the stuff we were doing up here. I think we did need that one though. Yeah, you do need this one. And maybe you still need the other one too, if you run all the tests. You don't. Oh, right, because when there's one element left, then we end up doing pivot plus equals 1. And left, I see, right. So let's take S or seats, log seats to sort the seats. They need to actually, they're both equal to n, so n log n, 2n log n, or maybe it would just be n log n because it'd be n log n plus n log n. Or would it be 1? That would just be 2n log n. I think it'd be n log n. And then we do n log n again because it'll be n students, and we do a binary search which takes log of n time to search. So it feels like this would be n log n. Ah, that is true. If we're matching students with the closest seat, then it would just be the... Yeah, we should. Yeah, that is the same thing. I didn't realize. There's actually no point in doing this while loop at all. So it was a combination of this solution and the first solution we did before, which was just to reduce and add the absolute value of the difference. But I didn't sort. That's unfortunate. But we have about 10 minutes left. I think the rant earlier got me a little bit sauced out, so I think we'll stop there for today.